See, I'll try to like share with you as much as I can, right? But we only have that much time. Okay. So let's get started first. See, at the end of the last hour, what I'm showing you is like usually we will like summarize data in this fashion, right? We do a filter, we do group by, we do summary, right? But if you do it this way, you tend to generate let me like also capture it so you can. Wait. If I capture this into a data frame, okay. Now, if we summarize data in this way, you will see a data frame like this, okay? So when you want to put customer group and product category together, right? Because you will have a lot of group and because you will have a lot of product category, right? So if you put it in this format, if you do a group by summary, the data will be very, very lengthy, right? Okay? Let me say it again. If you want to put customer and product together in one data frame, you will like it will become very, very lengthy if you like try to summary the data in this way, right? So in that case, we would prefer to have sorry, where is the data? In that case, we would prefer to have this matrix type of data structure, right? The data is the same, right? But we want to keep the data in kind of like a matrix, right? So the data is more compact, right? Otherwise, it would be very, very lengthy, isn't it, right? So in that case, I would usually I will use this xtab function, right? Okay, so you have the data here, and then xtab is actually easy to use. You just put on the row and also the column variable, and also the variable that you want to summarize. Okay, this is the variable that you want to summarize, and this is the row and this is the column, right? And then you will generate a metric like this. Okay, and this data format is much more compact than a data like this, right? It's too lengthy and it's very difficult to manipulate, isn't it? Okay, so that's why I am using this xtab type of things instead of using a data frame. Now, now that we have a data frame, now that we have a matrix, we can try to visualize the matrix to see whether we can find some pattern, right? Because so now our objective is to to correlate customer and product, right? It's not an easy thing to do because you have so many customers in the one way and because you have so many different products, right? So this is not an easy thing to do. If we have a data like this, if we simply like visualize the data in the Heatmap, right? Now using Heatmap is like it's kind of easy, right? But so far I'm using this like Heatmaply, which means that it's not just a Heatmap, it's interactive Heatmap, right? And it has some extra functionality. I'll explain that later. Okay. So so I have this like Heatmaply tool, okay, to generate interactive Heatmap for us, okay. and there are some if you call Heatmap directly, you will have to set up the font size, the grid line color type of things again and again, right? So I kind of write a helper function, okay, so I don't need to like type this graphical options again and again, right? Okay, so this is the way I do it, right? Usually I would like define a helper function. So because I want to call this like a lot of time, right? So I define the helper function first. So after I define this hmap1 function, every time I want to create the heat map, I simply give it the matrix, and then I specify the color scheme that I want to use, and then you will generate this. The tool would automatically generate this heat map for me, right? So heat map, right? So it mapped the value into the color, right? For example, in this cell, you can see that in this group, M4, F3, this customer group, right? Remember that we already labeled the customer into like 16 group, right? So in this M4, F3, now the column is actually the category ID, right? So this M4 F3 group, they buy the 560402 category for like $632,000, right? Okay, so this is heat map, right? It simply map the values into color. But as you can see that this heat map is kind of like useless, right? Because all of the color like is just here, right? So these are the M4 F4, M4 F3, and N3 F4. These are the customer group that their average contribution is like much higher than the other group, right? Okay. So if you directly like just simply do a metric like this and simply do a heat map, well, you can only identify the most the customer group that generate the most revenue, and also you can only identify two categories, right? These are the two large categories that everyone buy, right? Okay, so, and that is not useful, right? You don't need to do this, right? If you want to know that, you don't need to do this, isn't it? Right? Okay, so how can we solve the problem, right? Now this data is what we call by unbalanced data. Okay, you want to compare the buying pattern of these groups, but this group have they some of them buy a lot and some of them buy only a little, right? Okay, so if you want to compare their buying pattern, you need to normalize the data. Okay, what do I mean by normalize? If I can turn, this is the amount, right? Right now the value is actually the buying amount. Okay, so if I can convert the buying amount into the fraction, into the percentage, okay? Which means if I do a column sum and I divide the column by its sum, then all of the value here would become a percentage, isn't it? Right? Okay? And that's called normalization. When we want to compare a group of some group is very strong and some group are pretty weak, right? We want to compare them. We cannot compare them directly. Otherwise, we will see something like this. Okay, This is called unbalanced data. Okay? So one way to solve the unbalanced data, one way to make the originally not comparable data comparable is to do normalization. Okay? And usually we can do normalization by converting values, by converting amount into percentage. Okay? So if I do this, see, it's very easy to do normalization, right? So normalization can be done in a single line of code. That's why you want to use R, right? You can like manipulate data. You can manipulate the data, whatever you want, right? So as you can see, that I do a raw sum, right? Okay, and I divide the metric by the raw sum. Okay. So that after I doing this, I convert the MF0 into another metric called MF1. And here, because I'm doing this, right? So this is actually the fraction. Usually, originally this is the value, right? And here the values becomes a fraction, right? So you can see that the M4, F3, they buy 560201. They spend 16% of their money on this category. I can say that, right? And they spend like 15% of their money on 560402. Okay? You see the ideal, right? Okay? So after the normalization, I kind of convert the amount, the number here, into the percentage. So now every row, if you sum up, after doing this, if you do a row sum again, every row will sum up to 1, right? Isn't it? Right? Because you already convert the amount of revenue contribution into the percentage, right? So by converting amount into percentage, now every group, if you sum up the raw sum, they will have like always the same, right? So if I want to see the, for example, in this cell, I can see that M3F2, they spend about 17.35% of their money on this category, 560201. Okay? Okay? Right? So after doing that, now I can see different things, right? This heat map is much more informative than this one, isn't it? Okay? Now I can compare and I can see that different group, right? Different customer group, they the way their buying pattern are different from each other, right? Okay? You get the point? So the reason that we want to do this is we want to correlate customer and product or product category, okay? But doing this is difficult because you have a lot of customer and you have a lot of product, right? Okay? So in order to do that, you need to turn the data structure into a metric, okay? And visualize the metrics. But when you visualize the metric, you will find out that some of the group, they might not be compatible with each other, right? So you may have to do some normalization. So you can make the customer group comparable, right? Make them comparable. So you can see, so that you can see the distinctive buying pattern across the customer groups. Okay? So that is another technique that you should learn when you do data exploration. Get me? Any question up to this point? Okay? uh, the difficulty of exploration is that when you try to compare a lot of things together, right? So, so the most difficult thing to explore is the relationship between customer and product, right? Because you have like too many things, too many customer and too many product, right? So in order to do that, first of all, you need to do some selection, right? Okay. Now, in this analysis, first of all, I group the customer so that I only have like 16 group of customer, right? And the second thing I do is I only use the some of the category. I do not use them all. Okay, I just use the 100 category that generate most of the data, most of the revenue actually. Okay, so but even I reduce the scale, it's still difficult to see the pattern because the group are not comparable, right? So I use this normalization skill, right, to normalize the data, to convert the amount into percentage, so that I can see the distinctive buying pattern across the group. Okay, that's the idea of the thing. Okay. Now let's take a closer look at this chart, right? This heat map, it not only convert value into color, it actually do clustering, right? As you can see, it do clustering in this direction, and it also do clustering in this direction, right? Okay, so usually the a good heat map tool, it not only convert value into color, it actually would try to reorder the column and reorder the rows, right? It will reorder the row so that similar row would group together, right? So it makes it easier for you to observe, right? Make it easier for you to observe. Okay. So if you want to compare customer and if you want to correlate customer and product, you make it into a matrix and do some normalization, and then use the Heatmap tool. Then this Heatmap tool would actually not only that it would convert data into color, but it would also reorder the column and row so that similar row and similar column will group together. For example, these things are a group, right? These four are a group. M4, F4, M4, F3, M4, F2, and M4, F1. Okay, all of the M4 group, or I should say that the customer group that is in the fourth quantile, the customer with the largest average buying amount, right? They prefer to buy these two things, right? Because they have the similar buying pattern, right? Okay, and then the group in M3, they prefer to buy this one, okay, and this group, this M3 F2 is very, very distinctive because they spend most of their money on this thing, right? And if we look at this group, right? This is the M1 group, which means that these are the customer with the smallest average buying amount. They actually spend more money on this category, 110217. See that? Okay. So that in this technique, you will see, you will kind of try to figure out the different buying pattern of different group. Okay? Okay. So if you actually, as I say, right, you actually the Heatmap function is sophisticated, right? So besides this default functionality, you can actually specify a lot of things. For example, you can like you can make a chart like this, right? You can specify the color, right? You can cut the tree so that the tree is it cut the tree into like first group, second group, third group, fourth group, and fifth group, right? Okay. So Heatmap not only convert value into data, it will also reorder column, or it will also reorder the row, so that similar row will group together, right? Okay. So that's why we also teach Heatmap after we are teaching the clustering, right? Okay. So Heatmap is also a clustering tool, right? Okay. And this clustering tool is very, very useful when you want to correlate customer with data, right? You get the point? Okay. So here are some let me see how many times do we have? Okay, we almost. As I told you, right, EDA is all about comparison, right? We call explorative data analysis. It's all about comparison. Now, when you want to do comparison, the comparability is the key, right? Okay. If you put, otherwise your comparison, if your comparison look like this, and this chart is like not informative, isn't it? Right? So to make your comparison a good comparison, you need to make sure that you have comparability. Okay. So metric is a key data structure of a group comparison. Okay. This is the one thing that we learned. Okay. And second thing is like how to generate the metrics. It's actually apply a statistic by two categorical will create a metric. Okay. You can do it by t-apply. You can do it by x-tab, as I just showed you, right? Okay. If you apply statistic by two categorical variable, you will create a metric. Okay. So create a metric is easy. And I show you that Heatmap is the best visualization tool for metrics. Okay. Because it not only display the value in color, but also clustering the column and row according to their similarity, right? So that you can see the structure, isn't it? It not only just like turn the metric into a color map, it actually reorder the column and row so that you can see the structure within the matrix. Right? Okay. So it's not just the color, not just the color. It will reorder the column and row so that similar column and row will be clustered together so that it's easier for you to see the structure within your data, okay, within your matrix, okay. So if you have some extreme value or you have some unbalanced group, right? This extreme value or unbalanced group, they tend to degrade the effect of visualization, kind of like this, right? See, if you have one cell which has an extreme value, right? Then only that cell is red, right? The other thing would be like. So if your data is skewed, very heavily skewed, or between the group the data are unbalanced, then you need to do some transformation, right? Now, log transformation is good for extreme value, and the normalization skill that I already told you, right? Convert amount into ratio can help to improve the degraded. It's a remedy to the degraded heat map. Okay, so this is the thing that you need to know before you can use heat map to correlate your customer and product. Did you get the point? Any question about this? Okay. Okay, so in this section, I try to correlate customer and data, right? And because we have a large number of customer, we have a large number of product. First of all, you need the selection, and you convert the data into metric, and you use heat map to visualize the metric so that you can see the structure. Let me emphasize it again. In this heat map, you can see the structure within the data, right? You can see the pattern, you can see the structure within the data. And in order to do that, you might need to do some normalization, okay? Now the second key learning point that I want to explain to you that need to be explained is normalization versus standardization. Do you still remember? We just learned that normalization is simple, right? It's simply kind of like, usually you would just like turn the amount, turn the value into fraction, into ratio. But what is standardization? Do you still remember the standardization that we have done last week? Let me pull up the notebook to help you remember. These two things are actually different, okay? Where is it? Should be still remember that? When we do the airline data cases, okay? We do a scaling, right? We do a scale is actually standardization. The function name is called scale, right? So in R, if you want to do standardization, you call the scale function. So just give it a data frame. It's very simple. So you will do the standardization for you. But what does it do? It actually, the reason that we want to do scaling is because if you look into the data, you will see different scale, right? The scale of balance is like from 0 to like, well, more than 1 million, right? And the scale of like number of transactions is less than 100, isn't it, right? So before you do clustering, before you do dimension reduction, you want to do scaling, right? So that the weighting, when you do the analysis, when you apply the statistical method on the data, you want to do standardization first. Otherwise, what would happen, right? If I do clustering without doing the scaling, okay, what would happen? Anyone still remember? Now this is very important, okay? You have to remember it. Before I do scaling, before I do clustering, before I do dimension reduction, right? If I have variable different scale, right? I will do standardization, okay? With this scale function call, I do a standardization before I can do the clustering and dimension reduction. Why? Why should I always need to do that? Yeah, you want to make it in the same scale, right? Why you want to make them into a same scale before applying the function? Just still remember that the mathematical way, mathematically when we do the clustering or dimension reduction, we kind of map every data point into a variable space, right? Variable space. So if these variables are of different scale, right? The distance will be dominated by this large scale, right? By this balanced large scale, isn't it? Right? Because the scale is so large, right? So big, so that you will make all of the smaller scale invisible, right? In the space, I mean in the space, okay? So if we want to use distance to represent difference, okay? Now we need to make every dimension of the same weight, right? So scaling is kind of like to unify the weight of all of the variables that we are using, right? So that they have the same weight when we apply this statistical method on the data. We want to standardize the variable so that every variable has the same weight when we do further analysis, right? This is one way of doing, this is one reason that we do standardization. And standardization also help to do the comparison, right? Do you still remember this? In this bar plot, okay, the value that we show is the standardized value, right? Okay. If I see, this is the balance, and this is the different colors, the different variables, right? So because the different variables have different scale, right? It's impossible to plot them together, isn't it? Right? So standardization, just like normalization, is trying to make the originally uncomparable variable comparable, right? So in order to plot the variable of different scale in a single plot, okay, we need to standardize the data, right? Okay, so standardization and normalization, both of these techniques help you to establish the comparability. Okay? They help to establish the comparability between unbalanced group, between variables of different scales, right? They establish the foundation of comparison. Otherwise, you cannot compare them, right? So I told you, explorative data analysis is all about comparison. And before you can do comparison, you want to have a same base of comparison, right? And that's why normalization and standardization are important, okay? This is two skills that you need to know, okay? Today I'm just showing you the concept, right? And when you see something strange, right? If you make your plot and you see that in your plot, only one color is like very outstanding, the other color is very small, right? You have this comparability problem, okay? When you see a heat map that looks like this, right? You have the comparability problem, okay? So in order to solve the in comparability problem, you need to solve them before you can see the pattern within your data, before you can see the phenomena in the data, right? In a holistic and systematic viewpoint, okay? So in order to solve them, you have two choices, which is normalization and standardization, okay? There's a key difference between normalization and standardization. Okay, normalization, they are unipolar, and the value is between 0 and 1. Because normalization, they kind of like turn the amount, turn the value into ratio, right? And the ratio cannot be negative, isn't it? Okay? So normalization emphasizes ratio, right? And because it's ratio, so it's actually is within 0 and 1. Okay? It only has one direction. But standardization, they emphasize variations, okay? If you look into this plot, okay, the base of the plot is actually 0, right? Okay, and 0 is actually they are using the average value as the base of comparison, right? I mean, if I'm using ratio, right? So ratio is between 0 and 1, right? So the base of comparison is 0. You can say that, right? But if you are using standardization, the base of comparison is the average, okay? Is the average value of that variable. You know what? Get why? You understand me? Okay? Okay. So when you do standardization, the benchmark, right? The baseline for comparison is actually the average of the variable. Okay? Because you already standardized, so the average of each variable becomes 0, isn't it? So if you plot the standardized value, the 0 means the average. So everything that going downward is below average, right? Everything that going upward is actually above average, isn't it? Right? So this is standardization. And this is the way that when you do visualize with standardization. Okay? Now, oh, man. In Heatmap, you can do it this way, right? Okay, you can, because it's now there's a drawback. There is a disadvantage of standardization. I mean, in compared to normalization. Now, in this Heatmap, we will prefer to use ratio instead of doing standardization. Okay, can anyone tell why? So actually, I can do standardization on the data, right? And the plot would be exactly the same, not exactly, but it would be similar to what you have seen here. Okay, okay. I simply like standardize every row, then you will see like a similar plot. But one thing it would be very different, right? Is the value, right? Because here, this is the interactive plot, right? So if I go to this cell, I can see that M3, F2, they spend about 20% of their money on the category 560201, okay? Because it's percentage, so I can read the percentage directly, right? If I standardize it, I cannot tell the value of the standardized value is like statistically important, but it's difficult to understand, isn't it? Right? Okay? So the one advantage of normalization over standardization is that it actually the value actually means something, right? The value of normalization after you're doing the normalization, still means something. It means the percentage of money that M3, F2 spend on 560201. Okay? But if you do standardization, the value here is it's statistical value that you don't know how to interpret. Okay? Okay? So in the heat map, we would prefer to do normalization. Okay? Sometimes you need to do standardization in one way or the other. But in this case, actually, normalization is better. Okay? So this is the second important thing that I think you need to know before you're using the tool like Heatmap. Okay? Any question? So, comparability, right? Heatmap and normalization, standardization. So we still have like 10 minutes also. Is there any question that you run into when you're preparing your like midterm report that you want to discuss? No? Okay, if no further question, let me show you. I do not have time to go into the code for the fourth notebook, okay? But we can like take a quick look at it, okay? Just see the result. Now, the fourth notebook is about. I think I don't need this anymore, right? It's not working. You can hear me all right? Okay. So the fourth notebook is about product. Okay. As I show you here, most of the information in post data set is carried in the product column. Why should I say that? Because product column, in this product column, it tells you what product the customer buy, right? And you usually have a lot of product, right? Okay. Usually in the B2C environment, you will have a lot of product, right? So, so if you can use this data, right? If you can extract this data and put it into use, then usually you will have a lot of benefit by doing so, right? So this notebook, I try to tell you how to extract the information from this product ID column or categorical ID column, okay? So before anything, we can just like when we are dealing with customer, we choose the most profitable customer, right? So when we are deal with product and category, we always start with the most profitable category and most profitable product, right? That's the nature. And to do, it's easy to do so, right? Now, the difference is that every point right now here is one category, right? So you can actually see this category, right? The category is is here, right? And its margin, the revenue contribution and profit contribution, right? So you can do so, and as you can see that this is the margin, right? So there tend to be a negative correlation, right, between total revenue and margin, isn't it? Right? Okay, right. So so this product is important, right? Because it if you want to choose one of the category and you want to tell yourself that this category is the most important, I would choose this one, Because of what? I would say that this product category is the most important product category in top 5. Now, why do I say so? Anyone can guess? Now look into the dimension, right? The X dimension is profit, Y dimension is revenue, and this point is the rightmost point, right? So it means that this category generate the most profit. It has the largest profit contribution to you, right? So it's most important to you, right? So which product will generate more the most revenue for you? It's upmost, right? Isn't it? Right? So very easily you can see category by category, and of course you can do it in like, this is the top 300 profit, the 300 most profitable product, right? This is for category, right? And if you do this practice, you will see how to do that in product item, right? So this is product item. So you can do the same analysis with product item. It's quite similar to what we have done with customers. So I think we don't need to explain it again, right? Now, the second thing that I can show you is about we are running out of time. The second thing that I can show you is like, we can do customer segmentation by buying patterns, right? Okay, which means that like we can generate the metric, right? This is customer, and this is the product category. Okay, so I have a matrix. I have a customer category matrix, and in this end is customer. So they are like about 30,000 customer, and I want to do clustering directly on customer. Okay, I want to do clustering directly on customer based on their buying pattern on the top 50 categories. Okay, I want to do a clustering on 30,000 customer based on their buying pattern on the top 50 product category. Okay, so as you can see that I can like I can do a clustering very quickly in one line of code. Okay, this is k-means, right? Just give it the metrics. I told them the number of cluster that I want to generate. Okay, actually you can skip this one. It's not very important. Okay, so only one line of code, I can get the clustering vector. Now, look at this. I actually group them into 160 group. Okay, it's a lot. You will see that. Why should I? How should I handle so many groups, right? 160 is a lot of groups, right? Okay, but actually, let's go down and see the results. Okay, so out of this 160 group, actually I do not use them all. Okay, there's a typo here. It's rather than plotting all of the group, we only plot the group of appropriate size. So I do a filtering, right? Out of that 116 group, I only select the group size between 200 and 1000, right? Then I do the plot. So so that the X and Y is actually the average buying amount and average frequency of the group, and the color is the total profit, the size is the group size. Okay, so you can see that these are the I clustering them into 160, right? But if you observe the group size, they are some very small group, okay? So we don't need to look into the small group at all, right? Just discard them, okay? We only plot the important group, right? So we can see that now every bubble is a group, right? The bubble size is the size of the group, and the X, Y, and color represent the average buying amount, average buying frequency, and also the total profit contribution, right? Okay, okay. So now you have this customer group, okay. Now the beauty of this customer group is, if you do a heat map on their buying pattern, you will see a very, very specific buying pattern. Okay. For example, this is group 4, right? So I can see that the group 4 spend a lot of money on this category, and this category, right? You can see that almost every group have a unique buying pattern, right? The reason that every group have a very unique buying pattern is because in the beginning, when we do the clustering, remember, I'm using this to do the clustering, okay? Because the clustering matrix is actually the customer category metric, right? So if I cluster, if I use the cluster as the variable, okay, and do the clustering, okay. So in the product space, right, because this category is actually the product, right. So if I want to cluster my customer in the product space, okay, I should use the product category or product as the dimension, right? So if I cluster my customer in the product space, the group tend to have a very, very specific buying pattern, right? Okay, and that has a lot of advantage, right? Now, not only you can see the RFM type of characteristic of the group, you also know the buying preference of each of this group, right? Okay, that is another label that we can go into, okay, right? You see my point? The exercise here is like, right now I'm still using the customer product matrix, right? But instead of like just use heat map to product, I actually do a cluster analysis on that matrix, okay? And after I do the cluster analysis on the product space, my customer is actually grouped by their product reference, okay? And when you group customer with the product preference, actually you can, right? You know that this group of customer like to buy this one. That group of people like to buy that one, right? So it's a lot easier for you to profile your customer segmentation and design your marketing campaign, right? Isn't it, right? Because now you know the specific preference on each group, right? So clustering has a lot of different way to clustering, okay? Depends on the clustering variable that you are choosing to do the clustering, right? Clustering is a thing that you map your data point into a space, into a variable space. So depends on the variable you use, you actually cluster your data points in different way. Let me say it again. Clustering is done by mapping your data point into your variable space, right? So if you choose different variable right? So you will actually have a group of different characteristics, right? So you want to, in this example, I'm showing you that if you want to have a group of distinctive product buying behavior, okay? If you want to have group that across the group have distinctive product buying behavior, then you should use the product buying amount, right? You should use the product or category as a variable, right? Now I'm only using the top 50 category. In this data set, we have 2,000 category, right? Okay. Instead of using category, you can actually use product. And in this data set, we have more than 20,000 product, okay? That would go into the realm of big data computation, okay? You should heard this a lot, right? Big data, big data, big data, right? In the traditional way, we can handle like 200 variable. It's already a lot, okay? But nowadays, with the big data technology, we can actually, like, if you like to, you can actually do K-mean on 30,000 customer, over 20,000 products, okay? You can do clustering in this way, okay? But you cannot do this in this class. In our class, we cannot do that, okay? If you learn some big data technique, enable you to handle that things, right? But in our class, this is good enough, right? This is good enough to help you find the customer group with very distinctive product buying behavior. Okay, because of time, I think that's what I can tell you this week. And you have one more week to prepare your presentation, right? Okay, so do whatever you can and take the advantage of our TA session, right? We have one session Wednesday night and one session Friday afternoon. Okay, so get together. If you want to do it in the weekend, usually I will in my office in the weekend. Okay, so if you need help during the weekend, I'm also available in my office. Okay, so try to do more, and the more you practice, the more you would learn. Okay. Now, the last thing I want to tell you is we will not throw out this fun data set. Okay. In the next half of our class, we will keep using this one. Okay. So, but we will go into the other direction. It's not only just strategy. We are going into the specific operation, specific practical design, okay? Also using this data, okay? All right, so it's already overrun the time. So the class will dismiss here, and I'll see you next week, okay? So prepare your presentation. The first thing we will do is to see your presentation in the first hour of next week, okay? Okay? Okay, so that's all for today. I'll see you next week. Bye-bye.